Been progressing a little bit over the last year or so in this joiner project. It's taken a lot longer than I originally expected. I ran into a bunch of problems and it's just taken me some time to sort of work through everything. What started off is I wound up with the issue with the motor on here, and it's a direct drive that runs on this spindle here. And it's kind of a long story, but something's wrong with that motor. I think it has what you call insulation leak, and it's causing it to short, and so it's popping the breaker. And so I did put a lot of effort into trying to get that thing working, and it got to the point where I gave up on it. So what I ended up doing is I found another motor, and I made a separate video about this guy down here, and that's a 5 horsepower motor. And so I just decided what I wanted to do is have a motor that's just bolted on with some pulleys. So you can see there's pulleys now. I machined a pulley receiver for this guy here, and I put I can't think of the word right now, but that little insert that corresponds to a groove in this pulley to help transfer the power from the pulley to the spindle. So this is a double belt job. I think this motor weighs around 110 pounds, so I'm thinking it might put enough tension on this thing that I don't need to put a separate tensioning device, but we're gonna find out. Right now it spins fine without load, and so I'm going to put it under load and see what happens. And then if I need to, I'll put some kind of, screw-based tension device that like pushes on this thing and applies tension. I also built this rolling base, so there's wheels under there because this thing weighs 1,600 pounds, and if I need to move it, and there's a lot of times where I need to move it because you kind of see I'm running out of space. I got my planer down there, and I have this thing here and all this crap here that's not moving. And so if I want to do a really long board, I have a bay that's wide enough that I could pull it out a few feet and run like, something closer to like 12, 15 feet. I don't know if that scenario is ever going to play out. I've actually had to move it out before, and it's very heavy. And one of the most dangerous things with these 3-toe joiners, they made them 3 toes for a reason, and that's because basically you always need 3 points to have like stability. And so they made these with 3 points so that if the floor was uneven, you didn't have like a tilting rock between two, like if you had a short leg here or on the other side, so it wouldn't rock. And they did this with a lot of lathes as well. And so it runs really balanced and smooth, and there's no wobble to it, but it's tippy. So if I start pushing around on this, trying to move it, it can collapse this way very easily. In fact, I had this happen one time, and the motor wound up getting driven into the wall right there. Luckily, the wall supported it, and I was able to tip it back, and everything was fine. But just be aware that if you have one of these 3-toe joiners. And so for this rolling side here, I widened that thing out pretty good. And it seems like it doesn't like want to like trailer around too much. But if it does, I'm going to have to figure out some way to sort of clamp it. But it like right now, everything's tight, and so it hasn't been an issue. I also have these leveling feet that I put on here, and so those are like welded nuts there, and then you could just turn that down, it lifts it up, and then you can level it. And yeah, so I made this so that I can move it around. What I'm going to do today is I need to put a motor starter on this, and I had a previous motor starter from a 3 horsepower motor, which is that guy there. Now I'm moving to a 5 horsepower motor. These have circuit protection on them so that if the motor gets bound up or starts drawing a lot more amperage, then it's designed to, you don't burn out the coils in your motor or cause damage to other electrical components. And so what it'll do is it'll pop and sever the connection, and then you can troubleshoot and figure out what's wrong and fix it rather than your shop burning down, for example. Anyway, I bought one of these motor starters that's sized for a 5 horsepower motor, and I want to talk about that a little bit. Before I get into that, my plan here is that I have 3-phase power coming out of this outlet right here, and I'm going to put a cover on there to close all that out and use this plastic conduit. I think the way I'm going to do it is I'm going to put an outlet on that wall with a twist lock fitting. Because I want to be able to move this in and out, I can't hardwire the machine into the wall because obviously I wouldn't be able to get back there to disconnect it, and I don't want to be pulling around this machine and have it put excessive tension in the cables, etc. So I'm going to use a twist lock fitting that I can get my hands on, and then I'll bolt the motor starter and the switches and everything on the joiner itself, and then have a twist lock where I could just unplug it from the outlet, and then it'll be free to move around. I also have a couple other 3-phase outlets in this shop, so if I needed to move it somewhere else or connect it, it'd be able to do that without like a bunch of additional wiring. I have my twist lock fittings are in here. Let me get these out. And then I have an outlet around here somewhere. Yeah, so these are the ones I like to use. This is a 15-30P, and so it just stabs in and then clicks in. I think this might be the outlet. And the way they set these up is you can get 1 outlet per box. I mean, yeah, per conduit box, as far as I know. Here's the outlet. Just like you can see, this stabs in, and then you twist it so that it doesn't unplug. Okay, so I bought some stuff on Amazon. And this is cheap Chinese electronics, but I'm hoping it does all right, because the industrial ones from reputable companies like Allen Bradley, for example, will cost you in the thousands of dollars. This was like 50, 60, maybe $75. Yeah, so there's a couple parts of this, and I want to talk about how these motor starters work and why they're designed like this and why you need one. But way back in the old days, they didn't require these. And like I said earlier, the reason you want one is because you could set the amperage according to your machine. Right now it's set on 15 amps, but I could twist this till it gets to 18, which will correspond with normal running load for a 5 horsepower motor. They used to have switches like this where your L1, L2, L3, your 3 phases just plug in here. And then this guy has an on and off switch. So basically, it literally like just engages and disengages, and it contacts all 3 at the same time. And so I don't know if they're just using wall protection or I think they put fuses in series with these as a safeguard. And that way, if you went over current, over power, the fuse will pop. So this here is kind of a more modern version. You see them on old machines too, but for whatever reason, wasn't always required. That specific machine is 100 years old, like literally made in the 1920s. So the way this works is you plug your line power into here. And so for me, I have that conduit box right there. It's being fed from the one on the right. And so I get 220 voltage signal. So it's 2 hot wires. Both of them are 120, but it goes down inside the wall to that 3-phase converter. And then it goes through a motor, and the motor makes the 3rd leg, goes back up, feeds the circuit. There's some stuff they do inside of there to try to smooth out the power and everything, and then it goes up, and I just feed this box here, and it powers this saw. Let me see if I can get it in there. So look at that big boy right there. That lathe also, and a couple other things. I have a little bandsaw back there that's like around the corner. And so I have breakers in there for each one of those devices and outlets around the room. So I can plug into it. I just have to turn that RPC on, and then rotary phase converter. That wire comes out here and it goes up on the ceiling and pops it back down here to the outlet I just showed you. And so this guy, so the 3 wires that come out of the 3-phase breaker box plug into here. And then what this is a magnetic starter. And there's a way to wire this up so that what happens is it gets energized and the magnets like pop into engagement, and it activates all three of these circuits so that they're live and the power can flow through. And then it goes to this thing, and this is the over current protection, and then it goes out to your machine. Okay, the way this works, and I want to show this diagram real quick. There's a couple different ways of wiring this up, but the one that I'm going to use, what they're calling standard wiring here, you wind up with a switch box, and so that's what this guy is here. Little switch box, and I'm going to mount this to the face of that joiner, like on the front side. And these are just receptacles, and it's got a little seal that goes along this racetrack, and it just gets screwed together. And then there's two switches, there's on and off. And the way this works here, this is normally open. So when you can see right now, the contactor is like right here, and when I press the button, it contacts. So this is the on. It's normally like a disconnected circuit, and when you push the button, it closes the circuit, and you allow power to flow through there. And this one, this is normally closed, so you can see it's engaged in the circuit, and when I actually hold on, I think I got those backwards. Now here, what it is one side's normally open and one side's normally closed. So, and depending on which one you need, because I guess there's several different circuit arrangements, you wire it to one side of the switch or the other. So this one here is normally closed on both of these. So I'm going to click it, and so that opens the circuit and terminates the flow of electricity through these switches. And then if you go to the other side, they're normally open, and so there's a gap there you can see, and when I push the button, it closes the circuit. So these are basically a signal wire, and what happens is, okay, so this little diagram here, so you have your L1, L2, L3 in from line power, and then one of these legs gets wired over to your normally closed off switch. And then there's a continuity all the way to normally open 13. It's 14 normally open. It goes to the switch, and then the switch connects to the other side of that loop, your power loop. And so what happens if when you engage this on switch that's normally open, activates the magnet, and the magnet closes the circuit. And it continues to have power and activate the magnet because it just feeds off the circuit. But then if you want to terminate it, you push this off button and it opens it back up. That removes that signal to the magnet, and the magnet collapses back to its original position and disconnects all three of these wires simultaneously so it doesn't flow through. And then here, T1, T2, T3, these go to the three phase of your motor. This little circle right here with the pyramid under it is representing your motor. So all this crap on here, your wires, your three wires go in here. There's a connection you have to make between this. It'll go back out through a conduit into the switch box, and then the 14O is right here. It'll go back through the conduit to the on button, and then you wire everything up, and then this will come back out into the conduit to the motor, and it'll make it so you can turn it on and off. I like these mushroom buttons because they're easy to see and easy to push, and you can kind of if you get in a jam, you need to shut it down real quick, you could do that. So they don't just have those motor starters on three-phase machines. This is a two-phase machine here, or a single-phase, I'm sorry. One of the things I want to show is this button here. This is really like well thought out position, and the size of it's really good. And you can see how far it sticks out. It's about, 1.25 inches. And what this does is I could pull it to turn it on, and then if I wind up bending over the saw, I'm doing something, I get in trouble, I could just kick that with my knee and it turns it off, which I've had to do a couple times, because if you use these saws, you're holding material, and if you let the material go, it could shoot across the room because you got that blade spinning at like 3,500 RPMs, and the material is just sitting there. And as long as you hold it in place, it's not cutting. But if I was to let it go to reach down and get that switch, you could wind up putting yourself in a dangerous situation where you could get hurt. And so I like that. And I bought one just like it from Powermatic, and I'm going to rig it up so that I have one on this table saw here. Okay, so another scenario where this is valuable in comparison to something like this, like let's say I was using this, power's on, and I'm doing something, and then boom, the power goes out. So first thing I do is I walk away from the saw, and I'm like trying to figure out how to, if I popped a breaker or something's going on, to try to get the power to come back on. So when I'm doing that, you might have material in there, similar situation like I described before, and if the power comes back on, this machine will still be on and it'll start running, and it could cause some problems where it could cause damage or somebody could get hurt. So I mean, I could come up with 1,000 like Danger Dan examples of why this is not a good idea to have like a direct contact switch for that reason. So for this one, if you cut the power, it deactivates that magnet. You have to push the button again to turn it back on. So that's another kind of a benefit other than just the surge protection or circuit protection. So anyway, this video is getting pretty long. So rather than break into the meat and potatoes of how I'm going to install it, I'm going to kill the video right there. That information I just gave you, I think, is kind of a mystery to me when I first started getting into these three-phase machines. You know, a lot of this stuff is not intuitive, and if you've never done it before, or you know, if you don't have electrical background, it could be a barrier to getting you know, some nice woodworking equipment. And so just for reference, a lot of times, you know, big companies, they go out of business and they just auction off all their stuff. And you could get a machine like this for pretty decent price, and it's way more capable than anything you're going to buy today. I mean, this is a 5 horsepower motor. I could run a telephone pole through this thing. Literally with the 3 horsepower motor, I was able to hog out like a 1/2 inch of a cut. It wouldn't even bother it at all. I've never got to the point where I felt like it was going to stall, or, you know, the 3-phase motors run a lot quieter. They're more power and more balance because, you know, with a single phase motor, you have, you know, like you have a hot side, a neutral side. And so it's like a guy riding a bicycle with 2 pedals. And at the top of the pedal, like when your foot's at the top and your foot's at the bottom, you kind of have a power loss there. And so if you think about what a 3-phase motor, instead of dividing that 360-degree circle into 2 halves, you now have 3 pieces, and they're split by, I want to say, 120 degrees. So if you had 3 feet and 3 pedals, you would never get in that situation where one of your pedals isn't working. And so that's so you don't have that momentum loss, that potential for stall. And so they run a lot better. I think the main benefit, like I said, though, is that they're just really quiet compared to the single phase motors. But I bought this machine for $600. If I wanted to get a 12-inch joiner, just not even talking about quality, the weight, stability, all the other benefits of this machine, just if I went to Powermatic, for example, or Jet or whoever, and I want to get a 12-inch motor, 12-inch joiner, it's going to cost me like $6,000, maybe more than that, depending on what it is. I paid $600 for this just because a company went out of business and they needed to get it out of there so whoever the new owner of the building was could get in there. And so that's a possibility, and it opens doors for people to get really good equipment at low price. But you have to have the ingenuity to hook all the stuff up, to understand how it works. And then it comes with like sort of like a maintenance burden that is inherent with old machines. And so you have to have a little bit of know-how to try to keep them going. I think it's a fallacy to think that you're not going to have to do maintenance on like a new machine, because I've had to rebuild this $2,000 Powermatic saw. I had one of the castings sheared off. There's a little crank on it, and so it raises. And the casting quality that's made today in modern times is trash. And so it had a big inclusion in the casting, and so there was a stress concentration. My wife was rolling up the blade, and it got stuck, and she pushed on it a little too hard, and it just snapped that casting like a twig, and the whole saw fell down. And I had to tear it all apart. It took me like 3 weeks to get all the parts, to figure out what was wrong with it and what needed to happen. And then I had to wait for another 8 weeks from Powermatic to send me all the stuff, and they sent me the wrong stuff. And So, I mean, it cost me a lot of time. So I just want to be clear that even with these high-end, expensive, new modern machines, there's not a lot of design effort goes into them, and there can be problems too. And they're designing stuff for cost. They're trying to keep the weight down because they send these to the U.S. from China on a boat, and obviously there's economic things associated with that. The cost of metal, obviously, and transportation. They're trying to whittle down on pennies and dimes when they make these, and a lot of times they go too far, and you wind up in a situation where something breaks, and then you have to deal with it. Good luck if trying to find a new part for one of these machines as well. You may think they're still in production, or it's not that old, so you should be able to get parts. It's up to the company, man. They could discontinue parts, and you just be just as screwed as you would with a 100-year-old machine. The only benefit is this thing weighs 1,600 pounds, so if I had to scrap it for some reason, it would consume an entire weekend getting it out of here. So anyway, like I said, I'm starting to ramble, so I'm going to cut this video here, and I'm going to post it, and then I'm going to get into the second half of this, which is I'm going to locate a box on the back here. I'm going to put an outlet, and then do all my wiring, and I'll try to walk through that. Honestly, man, it's not that complicated, and it's probably going to be a boring video, but maybe somebody will get some ideas out of like what you need. Like, for example, these guys. This is something that you might not know even exists if you're never messed around with it. So, okay, thanks for watching, and look out for the second video.